Okay. The last thing we're going to talk about, talked about center, talked about shape, we talked about spread. So the last thing we're going to talk about is what we call measures of position. Positional measures are going to be your resistant measures. And remember, a resistant measure means that it's not affected by change when we say resistant. So far the resistant measure that we know of is going to be for the center. We know the resistant measure is the median. Remember, the median is based on a position, as opposed to a non-resistant measure like the mean, which is based on all the data. The median is not affected by any kind of change, or not dramatically affected by any kind of change. So when we talk about positional measures, what we're talking about are based on the data. Where does this measure lie in the data? And we've already talked about one of the positional measures, which is the median. The median lies at the halfway mark. So we're going to talk about more of them. And we're going to start with talking about what's called a percentile. A percentile means that a value sits at or below a certain position. So when I say percentile, I'm talking about a value that, say, specified value that sits at or below a certain percentage. One of the main percentiles you know already is the median. The median means half the data sits at or below it. So we start out by talking about what are known as fractiles. Fractiles just are numbers that they divide an ordered data set into equal parts. Key thing here is that the data has to be ordered. So you have to order your data when you look at any kind of percentile measure, because you're looking at the position based on the data. The most important fractiles you're going to talk about are going to be the quartiles. And the fractiles that divide the data, quartile just means, the word quart means 4, so it's going to divide the data into 4 equal parts. We call it the first quartile, or it's called also known as Q1, contains approximately 25% of the data. So you're breaking your data, 100% of the data, into 4 parts. The second quartile, also known as the median, contains approximately 50% of the data. And then the third quartile, or Q3, contains approximately 75% of the data. When we look at this data, then what that means is that Q1 and Q3 are basically going to be the respective medians of their half of the data. What that means is, when you look at the data, you're starting with your minimum value, sitting here, going all the way to your maximum value out here. So all the data sitting inside of here. If you break this into 4, so your first one is at Q1, your next one is at the median. We know the median is exactly halfway through the data. Then you have Q3. So notice here that Q1 is the halfway point to the halfway point, and Q3 is the halfway point to the max. So they're the medians of each one of their classes. All right. So again, first quartile, Q1, contains approximately 25% of the data. The second quartile, or the median, contains approximately 50% of the data. The third quartile, or Q3, contains approximately 75% of the data. And then Q1 and Q3 are the respective medians of their halves. And again, notice here you have a min value and a max value. So all the data sits out here 100%. The median sits at the middle. Notice Q1 breaks the min to the median in half, and Q3 breaks the median to the max in half. So they're the medians of each half of their sides of the data. If we combine, if we look at the measurement from the Q1 to Q3, if we look at this measurement right here, we get a value known as the IQR, or the interquartile range. So the interquartile range is a measure of position that measures, this is the range from Q1 to Q3. And because it's a range, we're finding the range. How do you find a range again? It's the max minus the min. Well, in this case, it's the IQR is going to be equal to Q3 minus Q1. And all this tells me is if you look back down here, we're breaking these into quarters. So here's 25%, here's 25%, here's 25%, and here's 25% of the data. In the IQR sits 50% of the data, and more importantly, it's the middle 50% of the data. So the IQR contains the middle 50% of the data. The good news here is that your calculators can do this for you as well. They're going to find everything for you. So if you look at this example, all you have to do is, we're going to type this into our calculator. So remember, press Stat, Edit, type in what you see. And this is concussion data, the amount of time it takes to recover from a concussion in days. So each one of these is days. So if you look here, there are 11 values because it's waiting for the 12th value. Remember to calculate the summary statistics. You're going to do stat, calc, 1 vars, set a list. I'll do L1, and then press enter. Notice that the mean sitting here is 44.9. The standard deviation sitting here is 19.44. Talked about standard deviation last time. Standard deviation is the average distance of values away from the mean. So in this case, if you bring it down to the units, it's 19 days away from the mean. S of x is what we're looking at, not sigma x. Sigma x is the population, which is always smaller than S of x. If you keep scrolling down, you'll see more data there. Let me show you more data down here. Notice here you have Q1 sitting at 33 and Q3 sitting at 52. So we want to find the IQR, where, and I'll actually do this by hand too. Let me do it by hand first. So let's 18, 33, or I'm sorry, 24, 33, 36, 43, 45, 47, 49, 52, 91. That's me ordering the data. To find the actual Q1 and Q3 by hand, all you have to do is find the median. Since it's 11 numbers, 11 divided by 2 is 5.5. So you're going to round it up to 6. So here's the median at 45. And notice my calculator says the median is also 45. Now, Q1 is the median of the lower half. So you have 1, 2, 3, 4, 5 numbers sitting here. So the median is going to be the third number, 33. Here's Q1. Up here you have one. Up here you should also have 5 numbers. 1, 2, 3, 4. I'm missing a number. Your median should be sitting at 52, which is here. I'm missing one of my numbers. I don't know which one it is. But it's there. So it should be sitting here at 52. Oh, I see it. 57. I'm missing number 57 actually out here. So it's 57 and 91. And the median sitting there at 52. So there goes your numbers. To find the IQR, the IQR is just 52 minus 33, which is 19. So the IQR is 19. And that means that the middle 50% of the data lies within 19 days of each other. You bring it to the thing. Now, the more important thing we're going to use the IQR for is the outliers. Outliers, we said earlier, when we talked about this, when we talked about the mean being a non-resistant measure, which means it was affected by outliers. An outlier is an extreme value that is not consistent with most of the data. We have a mathematical formula that's going to help us decide what an outlier is now. And here's how you find it. You have to set these things called a upper and lower fence. To find the upper and lower fence, the upper and lower fence is going to tell you whether the value is an outlier or not. If an observation X is less than the lower fence is calculated as Q1 minus 1.5 times the IQR. And the upper fence is calculated if X is greater than Q3 plus 1.5 times the IQR. So values sit less than this, There are outliers. If a value sits greater than this, it's an outlier. So we're using the data above. Are there any outliers in there? Here's what you would do. We know Q1 is 33. So that's 33 minus 1.5 times the IQR, which is 19. When you calculate that, you get a value of 4.5. The question is, are there any values in this data set up here that are lower than 4.5? So the answer there would be no. When you look here, there are no values less than 4.5. So there are no lower outliers. Now, upper outlier. So this one is Q3, which would be 52 plus 1.5 times the IQR. 52 plus 1.5 times 18. This one is equal to 80.5. Are there any values that are greater than 80.5? When you look at your data, you can see that the max value, 91 is an outlier. It's bigger than the actual upper fence. So this right here is how you calculate outliers, and we're going to use outliers to help us determine how to make box plots in the next section.